Hi, hello children. A very good evening to all of you. So welcome to Webmaster School Foundation program. So today let us discuss the weekend test paper which you wrote on Saturday, means on 1st of this month. So hope most of the students are writing the weekend examination. So every Monday we are discussing the weekend examination, so which you are writing on Saturday. So still if you have any doubt you can clarify them. So first let us discuss the paper which you wrote on Saturday. After that let us start our class. Okay. So welcome to class, my dear children. In last weekend test, the first question is, if a equal to x1 1 0 and a square equal to I, then the value of x is. Here four options are there. Option A is 0, option B is 1, option C is -1 and option D is 2. Okay. So you have to pick the correct option by solving the given problem. Here the problem is given as, if A equal to x1 1 0. So clearly that is a 2 cross 2 matrix, and according to the problem the condition is a square equal to I. A square is known as A into A, that is nothing but the matrix multiplication between A and A only, equal to I. I is nothing but the identity matrix of order 2 by 2. So here you must take the identity matrix I as 1 0 0 1 only, because according to the problem the matrix A is given as 2 cross 2 matrix. So that's why we must take I as 1 0 0 1. So first take LHS, where LHS is A square. Let us write A square as A into A. Multiply those two matrices, take RHS as 1 0 0 1 and compare the corresponding elements on both sides, and after simplifying you will get any one of these four options. So according to the given problem we have only one correct option. We have to pick that correct option by solving the given problem. Here we have A square equal to I. So we have A square equal to I. Let us write A square as A into A, where A is given as x1 1 0. So x1 1 0 into x1 1 0 equal to 1 0 0 1. So that is the identity matrix of order 2 by 2. In LHS we have the product of two matrices. Let us multiply them. So since these two are the 2 cross 2 square matrices, clearly we can multiply them. Take the first row of the first matrix and first column of the second matrix. So take x into x, x square plus 1 into 1, 1, x into 1, x plus 1 into 0, 0, x plus 0 is x only, 1 into xx plus 0 into 1, 0, that is x only, 1 into 1, 1 plus 0 into 0, 0, 1 plus 0 is 1, so equal to 1 0 0 1. So after multiplying the two matrices in LHS we got x square plus 1 x 0 equal to 1 0 0 1. So here if we compare on both sides, so LHS is a 2 cross 2 matrix, RHS is also a 2 cross 2 matrix, and we have the symbol equal to. We have the symbol equal to between these two matrices. So clearly according to the definition of equality of matrices we can compare the corresponding elements on both sides. If we compare these two elements you will get x square plus 1 equal to 1. If we take 1 to that side, x square equal to 1 minus 1 0. By taking square root on both sides you will get x equal to 0. Or we may compare these two elements. Here also we are getting x equal to 0, here also we are getting x equal to 0. So according to the options we can take option A is the correct option. Okay. So this is the given matrix, that is A, x1 1 0, and according to the problem we have the condition A square equal to I. Write A square as A into A, multiply these two matrices and equal to 1 0 0 1. So you compare the corresponding elements on both sides, simplify, we got x equal to 0. Very simple problem, that is option 1. Next let us look at this problem. So here we have the determinant. If we have the two lines on both sides for the given element, then we have to consider that as the determinant only. If we have the square bracket on both sides, then we can consider that as the matrix only. Okay, now we have to expand this. After expanding this 3 cross 3 matrix, so we will get any one of these 4 options. Option A is 0, option B is 1, option C is ABC plus 2FGH minus AF square minus BG square minus CH square. Option D is given as AF square plus BG square plus CH square minus ABC minus 2FGH. Oh, okay. Now let us expand the determinant of the given matrix. So this is a 3 cross 3 matrix. We know how to find the determinant of a 3 cross 3 matrix. When a 3 cross 3 matrix is given, to expand the determinant of that matrix, simply take the elements of the first row, but it is not necessary to take the elements of the first row only. You may consider the elements of second row, or you may consider the elements of third row. But in general, let us consider the elements of the first row. For the given matrix, the elements of the first row are A, H, G. Multiply the element A with its cofactor, multiply H with its cofactor, multiply the element G with its cofactor. After getting them, add them, you will get any one of these 4 options. Okay. Now let us consider the elements of the first row. The first element of the first row is A into the cofactor of A. We have to multiply each element of first row with their corresponding cofactors. So we know corresponding cofactor means minus 1 power I plus j into minor of an element in ith row and jth column. But every time it is not necessary to multiply the minor by minus 1 power I plus j, simply plus minus plus. Plus minus plus. So for the element A, you will get plus. So that's why by eliminating the row and column containing A, the remaining elements are B, F, F, C. Determinant B, F, F, C. Next for H, you will get the sign minus. So that is minus H into so a cofactor of H. Cofactor of H means we have to eliminate the row and the column containing H, that is first row and second column. The remaining elements are HFGC plus G into cofactor of G. By eliminating the row and column containing G, eliminate this row, this column, the remaining elements are HB, G, F, expanded. So this is a 2 cross 2 matrix, this is a 2 cross 2 matrix, this is a 2 cross 2 matrix. Expand the determinant of those 2 cross 2 matrices. You will get A into B into C, BC, minus F into F, F square, minus H into C, HC or CH, minus F into G, minus GF, plus G into H into F, HF, minus B into G, PG. Now let us simplify that. You will get any one of the given 4 options, where this is ABC minus AF square minus CH square minus of minus plus HFG or FGH. H into GF, that is FGH, plus here also we have G into HF, FGH, minus G into BG, that is minus BG square. So by simplifying this, so by writing the similar terms at one place, we have ABC, FGH plus FGH is 2FGH minus AF square minus BG square minus CH square. According to the options, we have ABC plus 2FGH minus AF square minus BG square minus CH square, that is option C. So simple problem. Here the given matrix is a 3 cross 3 matrix. We have to find the determinant of this 3 cross 3 square matrix. We know how to find the determinant of a 3 cross 3 matrix. Simply take the elements of the first row, multiply the elements of the first row with their corresponding cofactors and add them. You will get the determinant of the given 3 cross 3 matrix. So take the first element of first row, that is A, cofactor of A, that is B, F, F, C. Next minus H into cofactor of H means eliminate the row and column, that is HF, GC, plus G into cofactor of G, that is HB, GF. So since these 3 matrices are the 2 cross 2 matrices, expand them. So we know how to expand a 2 cross 2 matrix. So after expanding and simplifying, we got ABC plus 2FGH minus AF square minus BG square minus CH square, that is option C. Next, matrix 1, 3, 3, 10 inverse. Inverse is nothing but inverse of the given matrix. If you suppose that this is a matrix A, find A inverse. A inverse is nothing but 1 by det A into adjoint A. But for a 2 cross 2 matrix, we know if A equal to A, B, C, D, then A inverse equal to 1 by A, D minus B, C, D minus B minus C, A. Simple. Okay. So, we have to find the inverse of this matrix. If we suppose that this matrix is A, now we have to find A inverse. Here we know one shortcut trick, but that is for 2 cross 2 matrix only. Generally, to find the inverse of A matrix, we have to take A inverse equal 1 by det A into adjoint A. First, we have to find det A for the given matrix and adjoint A for the given matrix. We must verify whether the given matrix is a square matrix or not. We can find the inverse for the square matrices only. So, that is why. So, that is general form according to the definition of inverse of a matrix. A inverse equal 1 by det A into adjoint A. But when a 2 cross 2 matrix is given, we know one shortcut formula, that is if A equal to A, B, C, D, if A equal to A, B, C, D, then A inverse equal to 1 by AD minus BC into D minus B minus C A. So, this is the formula for finding the inverse of the given 2 cross 2 matrix. So, by comparing 1, 3, 3, 10 with A, B, C, D, A equal to 1, B equal to 3, C equal to 3 and D equal to 10. Now, the inverse of this matrix is 1 by AD minus BC. 1 into 10, 10 minus 3 into 3, 9. The formula is 1 by AD minus BC, D minus B, where D is 10, minus B means minus 3, minus C minus 3, A is 1, where 10 minus 9 is 1. So, clearly, so that is 10 minus 3 minus 3, 1, 10 minus 3 minus 3, 1. According to the options, we have B. So, we can use this formula when the given matrix is a 2 cross 2 matrix. If the given matrix is a 3 cross 3 matrix, then we can use the formula A inverse equal to 1 by det A into adjoint A. But here we have the 2 cross 2 matrix. So, that is why if A equal to A, B, C, D, so this is the shortcut formula for finding the inverse of a 2 cross 2 matrix. If A equal to A, B, C, D, then A inverse equal to 1 by AD minus BC, D minus B minus C A. So, according to this formula, the inverse of the given matrix is 10 minus 3 minus 3, 1. So, this is also just like the above problem. So, here also if we suppose that this is the matrix A, again 1 by AD minus BC, D minus B minus C A, 1 by AD 3 into 5, 15 minus 7 into minus 2 plus 14. So, that is minus 14 into D minus B minus C A 5 minus B minus of minus plus 2 minus C minus of minus plus 7 A, that is 3, where 15 minus 14 is 1. So, that is 5 2 7 3. According to the options, we have option B, just like the above problem. Here also this is a 2 cross 2 matrix. So, we know how to find the inverse of the 2 cross 2 square matrix. So, simple, 1 by AD minus BC, D minus B minus C A. By using that formula for the given problem or given matrix, the inverse of the given matrix is 5 2 7 3. Next, this is also just like the above problem, but here we have to multiply A inverse by 8. So, 2 3, 2 minus 1. Here we have to find 8 into A inverse. Again, A inverse is known as 1 by AD minus BC, D minus B minus C A. So, after getting A inverse, if you multiply that by 8, you will get any one of these 4 options. So, that is 8 into A inverse, that is 1 by AD minus BC, 2 into minus 1 minus 2 minus 3 into 2 6 into D minus 1 minus B minus 3 minus C minus 2 A is 2, where minus 2 minus 6 is minus 8. So, that is 8 into 1 by minus 8 into minus 1 minus 3 minus 2 plus 2 only. Here we have 2 only. So, here we have 2, that is 2, where 8 get cancelled, we have 1 by minus 1, that is nothing but minus 1 only. So if you multiply by minus, minus half minus plus 1, minus half minus plus 3, minus half minus plus 2 and minus 2. So 1, 3, 2 minus 2 by observing the option, that is option D, 1, 3, 2 minus 2. So if A equal to 2, 3, 2 minus 1, find 8 into A inverse. In the above two problems, we found A inverse. Here also we have to find A inverse. After getting A inverse, we have to multiply that by 8. 8 into A inverse. Here A inverse is nothing but 1 by AD minus BC, D minus B minus CA. So by applying that formula, 8 get cancelled, we have minus 1. If you multiply each element of this by minus 1, we got 1, 3, 2 minus 2, that is option D. So here also we have to find xy20 inverse, that is nothing but we have to find the inverse of a 2 cross 2 matrix. So before finding the inverse of this 2 cross 2 matrix, we have to get the values of x and y. To get the values of x and y, according to the problem, we have if xy cube 20 equal to 1820, here we have to compare the corresponding elements on both sides. We have x equal to 1. X equal to 1. Here we have y cube equal to 8. 8 can be written as 2 cube. Y cube equal to 2 cube. So 8 can be written as 2 cube. Here by comparing on both sides, y cube equal to 2 cube. Here on both sides the powers are same. So that's why by comparing the bases, we got y equal to 2. Here the value of x is 1 and the value of y is 2. By substituting these values here, you will get xy20 inverse. So that is 1, y is 2, 2, 0 inverse. So we have gotten the values of x and y by comparing the corresponding elements on both sides of these two matrices, x equal to 1 and y equal to 2. By substituting these values x and y here, we got 1, 2, 2, 0 inverse. Now we have to find the inverse of this matrix. Clearly this is a 2 cross 2 matrix. Again by using the formula 1 by AD minus BC, D minus B minus C, A. 1 by AD, 1 into 0, 0, minus 2 into 2, 4. D means 0, minus B minus 2, minus C minus 2 and A is 1. So where 0 minus 4 is minus 4, 0 by minus 4 is 0, minus 2 by minus 4 is 1 by 2, minus 2 by minus 4 is 1 by 2, minus 1 by 4. So 0, 1 by 2, 1 by 2 minus 1 by 4 by observing the options. So option D is the required option. Very simple problem. First let us find the values of x and y by comparing the corresponding elements on both sides of these two matrices. By comparing the corresponding elements, we got x equal to 1 and y equal to 2. After getting those values x and y, substitute them here, xy20 inverse, where x equal to 1, y equal to 2. So 1, 2, 2, 0 inverse, that is nothing but the inverse of a 2 cross 2 matrix. So 1 by AD minus BC, D minus B minus C, A. Apply that formula. We got 0, 1 by 2, 1 by 2 minus 1 by 4. That is option D. Next children, so this is, here we have two matrices A and B. For these two matrices A and B, we have to find B inverse, A inverse, hold inverse. Okay. For these two matrices A and B, we have to find B inverse, A inverse, hold inverse. Actually general, if you want to find generally, first we have to find B inverse by doing 1 by AD minus BC, D minus B minus CA. Find A inverse 1 by AD minus BC, D minus B minus CA, multiply them, again you will get a matrix. For that matrix again we have to find inverse by using the same formula 1 by AD minus BC, D minus B minus CA. But we know the properties of inverse of a matrix. According to the properties of inverse of a matrix, we know one property, that is AB hold inverse equal to B inverse into A inverse. So AB hold inverse equal to B inverse into A inverse. We know this property according to the properties of inverse of a matrix. Now let us use this property for the given problem. Here we have B inverse into A inverse hold inverse. B inverse, A inverse, hold inverse. If we compare this with AB hold inverse, in place of A we have B inverse, in place of B we have A inverse. So that's why B inverse, that is A inverse hold inverse into A inverse. In place of A we have B inverse. So B inverse hold inverse. Again we have one more property, that is A inverse hold inverse equal to A. According to the properties of inverse of a matrix, this is one property, that is A inverse hold inverse equal to A. So first let us find the inverse of the given matrix. After getting that, if we find the inverse again, then you will get the given matrix only. That is nothing but A inverse hold inverse equal to A. So that's why here A inverse hold inverse can be written as A and B inverse hold inverse can be written as B. That's why this is A into B. According to the problem, we have A equal to 2, 2 minus 3, 2 and B equal to 0 minus 1, 1, 0. So that is 2, 2 minus 3, 2 into B, where B is given as 0 minus 1, 1, 0. Clearly these two matrices are 2 by 2 square matrices, so we can multiply them. Take first row here, first column, 2 into 0, 0 plus 2 into 1, 2, that is 2. 2 into minus 1 minus 2 plus 2 into 0 0, that is minus 2. Minus 3 into 0 0 plus 2 into 1 is 2, that is 2. Minus 3 into minus 1 plus 3, 2 into 0 is 0, that is 3. So 2 minus 2, 2, 3. 2 minus 2, 2, 3 according to the option, that is option A. Just simple problem. Here we have two matrices A and B. Find B inverse, A inverse, hold inverse. Find B inverse, A inverse, hold inverse. Simple. B inverse, A inverse, hold inverse. According to the properties of inverse of a matrix, we have one property. If A comma B are two square matrices of same order, then AB hold inverse is known as B inverse into A inverse. By using this formula, we can write B inverse, A inverse, hold inverse as A inverse hold inverse into B inverse hold inverse. Again we know one more property, that is A inverse hold inverse equal to A. According to that, we can write this as A. B inverse hold inverse can be written as B, A into B. A is given, B is given, multiply them, we got 2 minus 2, 2, 3. Next, the inverse of the matrix. The given matrix is a 3 cross 3 matrix. So when a 2 cross 2 matrix is given, we know A inverse equal to 1 by AD minus PC, D minus P minus CA. But here the given matrix is a 3 cross 3 matrix. If we suppose that this is a matrix A, now the inverse of A, that is A inverse. When a 3 cross 3 matrix is given, to find A inverse, we know the formula. A inverse equal to 1 by det A into adjoint A. So this is the formula. So first let us find det A for the given matrix. Next let us find adjoint A. After getting them, substitute them in A inverse equal 1 by det A into adjoint A. After simplification, you will get any one of these four options. So first let us find determinant of A. So since this is a 3 cross 3 matrix, we have to multiply the elements of the first row with their corresponding cofactors and we have to add them. So 0 into cofactor of 0, eliminate this row and this column. The remaining elements 0, 0, 0, 1. So 0 into 1, 0, minus 0 into 0, 0. So that is 0 minus 0. Next minus 1 into plus, minus 1 into. Eliminate this row, this column 1, 0, 0, 1. 1 into 1, 1, minus 0. Next plus 0 into, eliminate this row and this column 1 into 0, 0, minus 0 into 0, 0. So 0 into something, this is 0, this is 0, 1 minus 0 is 1, this is minus 1. So det A is minus 1. Det A is minus 1. Next we have to find adjoint A. Before finding the adjoint of the matrix, we have to find the cofactor matrix. So we have to find the cofactor of each element of A and we have to replace the elements by its cofactor. Then you will get a matrix B. If you interchange the rows and columns of the matrix B, that is nothing but B transpose, that is nothing but adjoint A. So first let us find the cofactor matrix of A. Here I am taking the cofactor matrix of A as B. Let B be the cofactor matrix. Let B be the cofactor matrix of A. Now 9 elements are there. Let us find the cofactors of those 9 elements. We will get B equal to, so according to the definition of cofactor, we have to multiply the element in ith row and jth column by minus 1 power I plus j. But we know one shortcut, that is plus or minus alternately. For a 3 cross 3 matrix, we can take plus, minus, plus, minus, plus, minus, plus, minus, plus. Let us take the signs plus and minus alternately. Now take the first element 0. The cofactor of 0 means we have to eliminate the row and column containing 0, that is first row and first column. With the remaining 4 elements, we will get the determinant. So if you multiply that by plus, you will get the cofactor of 0. So 0, 0, 0, 1, 0 into 1, 0, minus 0 into 0, so that is 0 only. That is 0 only. Plus into 0, that is 0 only. Next, take 1, eliminate this row and this column. To find the minor of 1, we have to eliminate the row and column containing 1. That is nothing but first row and second column. The remaining elements are 1, 0, 0, 1, 1 into 1, 1, minus 0 into 0, 0, 1 minus 0 is 1, but here the sign is minus, that is minus 1. Next, take the element 0, eliminate the row and column containing 0, that is nothing but first row and third column. The remaining elements are 1, 0, 0, 0, 1 into 0, 0, minus 0 into 0, 0, 0 minus 0 is 0 only. Here the sign is plus, that is 0 only. Next, take the element 1, eliminate the row and column containing 1, means first column and second row. The remaining elements are 1, 0, 0, 1, 1 into 1, 1, minus 0 into 0, 0, 1 minus 0 is 1 only. But here the sign is minus, so that's why this is minus 1. So next take, this is minus 1. Next take the element 0, eliminate the row and column containing 0, that is nothing but second row and second column. The remaining elements are 0, 0, 0, 1, 0 into 1, 0, minus 0 into 0, 0, that is 0 minus 0, 0. Here we have the sign plus, that is 0. Next take the element 0, eliminate this row and this column. The remaining elements are 0, 1, 0, 0, 0 into 0, 0, minus 1 into 0, 0, 0 minus 0, 0. Here the sign is minus, minus 1 into 0, that is 0 only. Let's take third row, take 0, eliminate this row and this column. The remaining elements are 1, 0, 0, 0, 1 into 0, 0, minus 0 into 0, 0, 0 minus 0 is 0. Here the sign is plus, that is 0. Let's take the element 0, eliminate this row, this column, 0, 0, 1, 0, 0 into 0, 0, minus 0 into 1, 0, 0 minus 0 is 0 only. So this is 0. Take the last element, that is nothing but 1, eliminate the row and column containing 1, means by eliminating third row and third column, the remaining elements are 0, 1, 1, 0, 0 into 0, 0, minus 1 into 1, 1, that is minus 1. Here the sign is plus, that's why this is minus 1. This is the cofactor matrix of A only, but we have to find adjoint A. How can we get adjoint A? Simple. Just transpose the matrix B, means we have to interchange the rows and columns of matrix B, then you will get one matrix, that is nothing but adjoint A. So therefore adjoint A equal to B transpose equal to 0 minus 1 0 minus 1 0 0 0 0 minus 1 by interchanging the rows and columns. So 0 minus 1 0 minus 1 0 0 0 0 minus 1. Now we have det A and adjoint A. Now to find A inverse, let us use that formula, that is A inverse equal to 1 by det A into adjoint A. Therefore A inverse equal to 1 by det A, where det A is minus 1 into adjoint A. Adjoint A is nothing but 0 minus 1 0 minus 1 0 0 0 0 minus 1, where 1 by minus 1 is nothing but minus 1 only. So minus 1 into 0 0, minus half minus plus 1 0 1 0 0 0 0 1. Let us observe the options. We have 0 1 0 1 0 0 0 0 1, that is option A. Okay. So this is a 3 cross 3 matrix. When a 2 cross 2 matrix is given, we know how to find the inverse of that matrix simply 1 by AD minus PC D minus P minus CA, but here the given matrix is a 3 cross 3 matrix. To find the inverse of a matrix, the formula is known as A inverse equal to 1 by det A into adjoint A. First let us find det A. So we know how to find the determinant of a 3 cross 3 matrix. Simply take the elements of the first row, multiply those elements with their corresponding cofactors and add them. Then you will get one value, that is nothing but the determinant of this matrix. Next, to find the adjoint of the given matrix, first let us find the cofactor matrix. Here I am taking B is the cofactor matrix of A. To get the cofactor matrix of A, here total 9 elements are there. So for every element we have to find the cofactor, and in place of that element we have to replace its cofactor. So here we will get 9 cofactors. So this is a cofactor matrix. If we find the transpose of B, that is nothing but by interchanging the rows and columns of B, then you will get adjoint A. After getting adjoint A and det A, substitute them here. A inverse equal to 1 by det A into adjoint A. So after simplification we got the inverse of the given matrix. So here also the inverse of this matrix, we can do this just like the above problem. Here also if we suppose that this is a matrix A, so here also to find the inverse of this matrix, use the formula A inverse equal to 1 by det A into adjoint of A. Find det A just like the above problem. First find the determinant of A, 3 into cofactor of 3 plus 5 into cofactor of 3 plus 7 into cofactor of 7. After simplifying you will get one value, that is nothing but the determinant of A. Take B is the cofactor matrix of A, total 9 elements are there. Find the cofactor of each element and replace those cofactors here. In place of 3, write cofactor of 3, in place of 5, write cofactor of 5, like the total you will get 9 cofactors, that is nothing but the cofactor matrix, that is B. By interchanging the rows and columns of the matrix B, you will get adjoint A. So adjoint A equal to B transpose. After getting det A and adjoint A, substitute them here. A inverse equal to 1 by det A into adjoint A, simplify them, you will get any one of these 4 options, just like the above problem. Like the last question, A inverse hold, this is just property only. In the previous problem also we discussed this property. According to the properties of inverse of a matrix, we know A inverse hold inverse equal to A only, that is option C, simple. So these 10 questions were asked in last weekend examination. So dear students, so hope all of you wrote these 10 questions. Still if you are feeling any problem as doubt, simply once recap them. So previously I told you there is one icon in our webmaster app, that is ask a doubt icon. So by clicking that you can ask your doubts 24 by 7. 24 by 7. After getting your doubt we can solve them and we can send it to you. So that's why keep asking your doubts. So this is the weekend examination. Now let us start the class. So already in previous class we did some problems relating to inverse of a matrix. So we discussed the definition of inverse of a matrix and properties of inverse of a matrix, and we did some problems relating to that concept. So we did some mains model problems. Let us continue them. So mains model problems, already we did some problems. So I thought 4 to 5 problems were completed. So here the next problem is a square non-singular matrix satisfies A square minus A plus 2I equal to O. That is a null matrix, not 0. That is a null matrix. Then A inverse equal to, so I minus A by 2, I plus A by 2. So actually when a matrix is given, to find A inverse the formula is known as 1 by det A into adjoint A. But here the matrix is not given. The matrix equation is given. The matrix equation is given as A square minus A plus 2I equal to O, then A inverse equal to, where I is the identity matrix. I is the identity matrix. A square non-singular matrix. Here A is given as a non-singular matrix according to the definition that A not equal to 0. Remember children, to find the inverse of a matrix, A must be a non-singular matrix. If A is a singular matrix, that is nothing but that A equal to 0, then the inverse of the given matrix doesn't exist, because according to the formula we know A inverse equal to 1 by det A into adjoint A. If we get det A equal to 0, 1 by 0 is infinity, means that is not defined. So that's why before finding the inverse of a matrix A, we have to check whether A is singular. Simply by expanding the determinant of A, if we get 0, that is singular. If we get a non-zero number, that is non-singular. Simple. Now, but here the matrix A is not given. Here we have the matrix equation like this: A square minus A plus 2I equal to O. Then A inverse equal to. Here the given equation is A square minus A plus 2I equal to O. O is nothing but null matrix. O is nothing but null matrix. I is nothing but the identity matrix. So A square minus A plus 2I equal to O. Here we have to get A inverse. We have to get A inverse. A inverse may be any one of these four options: I minus A by 2, I plus A, or option D, I plus A by 2. Here A square can be written as A into A. A square can be written as A into A. Here let us multiply on both sides by A inverse. By multiplying on both sides by A inverse, you will get A inverse into, where A square can be written as A into A. A into A minus A inverse into A plus 2 into A inverse into I equal to A inverse into O. That is nothing but null matrix, where A inverse into A can be written as A inverse into A minus, we know if we multiply the given matrix with its inverse, then we will get identity matrix according to the definition of inverse of a matrix. If you multiply the given matrix by its inverse, then you will get an identity matrix. So that's why here A inverse into A can be written as I plus 2 into A inverse into I. 2 into A inverse into I. If you multiply the given matrix by the identity matrix, then you will get the same matrix. That is nothing but A inverse only. Here I is known as the multiplicative identity. According to the properties of multiplication of matrices, we know one property, that is multiplicative identity. According to that property, if you multiply the given matrix, by an identity matrix, again you will get the same matrix. So that's why here A inverse into I is A inverse only, that is 2 into A inverse into O is null matrix. If you multiply any matrix by the null matrix, again you will get the null matrix only, so that's why that is 0. So O, here we have A into I equal to A only. If you multiply any matrix by the identity matrix, then you will get the same matrix. Again, according to this, A inverse into A can be written as I into A minus I plus 2 into A inverse equal to O. Again, I into A can be written as A minus A plus 2 into A inverse equal to O. Here we have to get the value of A inverse. So that's why let us take A minus I to that side. By taking A minus I to that side, you will get 2 into A inverse equal to I minus A. By dividing on both sides by 2, you will get A inverse equal to I minus A by 2. According to the options, we have option B. A inverse equal to I minus A by 2. Okay. So when the matrix A is given, to find the A inverse of the given matrix, we know the formula: A inverse equal to 1 by det A into adjoint A. But here the matrix is not given. The equation, the matrix equation is given. The matrix equation is given, that is A square minus A plus 2I equal to O, where I is the identity matrix and O is the null matrix. Here let us write A square as A into A. So A into A minus A plus 2I equal to O. Here let us multiply on both sides by A inverse. Let us multiply on both sides by A inverse. You will get A inverse of AA minus A inverse into A plus 2 into A inverse into I equal to A inverse into O. O is nothing but the null matrix. According to the associative law of matrices, multiplication of matrices, we can write A inverse into AA as A inverse into A minus A inverse into A is known as I. If we multiply the given matrix by its inverse, then you will get the identity matrix. So that is I. So I plus 2 into A inverse into I. If you multiply the given matrix by the identity matrix, then you will get the same matrix where I is known as the multiplicative identity. So that's why I into A minus I plus 2 into A inverse equal to O. Again I into A can be written as A minus I plus 2 into A inverse equal to O. So from this we can write 2A inverse equal to, by taking these two terms to RHS, we can write I minus A. But here we have to get the value of A inverse. To get A inverse, let us divide on both sides by 2. So A inverse equal to I minus A by 2. Next problem, the inverse of a symmetric matrix if exist. Exist means we must take a symmetric matrix as non-singular symmetric matrix. Then only we can find the inverse of the given matrix. If the matrix is a singular, means if the determinant of the given matrix is 0, then it is not possible to find the inverse of the matrix. So that's why here we have if exist. See, the inverse of a symmetric matrix if exist is, options are given as A symmetric matrix, option B is given as a skew symmetric matrix, option C is given as a diagonal matrix, option D is given as none of the above. These 4 options are given. Here let us solve this problem by taking one example. According to the problem, the inverse of a symmetric matrix, let us consider one matrix A as a symmetric matrix. Here you may take the matrix A as your wish. You may take a 2 cross 2 matrix or 3 cross 3 symmetric matrix, but the matrix must be a symmetric matrix. So here let us consider one example. So that is A equal to 1 to 2 1. It is not necessary to take 2 cross 2 matrix only. You may take 3 cross 3 matrix. Here just we have to check the inverse of a symmetric matrix when it exists is symmetric matrix, skew symmetric matrix, diagonal matrix, none of these. Here let us consider let A equal to 1 to 2 3. So clearly this is a symmetric matrix. Symmetric matrix according to the definition, A transpose equal to A or A dash equal to A. A transpose equal to A or A dash equal to A. So A transpose equal to A according to the definition of a symmetric matrix. Here by finding the transpose of this matrix, again we are getting the same matrix, that is why this is the symmetric matrix. Now let us find the inverse of this matrix. So this is a 2 cross 2 matrix, we know 1 by AD minus BC, 3 minus 2 2 is 4, D 3 minus P minus 2 minus C minus 2 and A is 1, where 3 minus 4 is minus 1, that is 3 minus 2 minus 2 1. Where 1 by minus 1 is minus 1, that is minus 3, minus half minus plus 2, minus half minus plus 2, minus 1. Here if we find the transpose of this matrix, so minus 3 to 2 minus 1, where first column minus 3 2. Here if we find A inverse whole transpose, so that is minus 3 to 2 minus 1, that is nothing but this matrix only, that is A inverse. So A inverse whole transpose equal to A inverse means the inverse of this symmetric matrix is also a symmetric matrix. So that is option A. So here you may consider 3 cross 3 matrix also, but here the condition is the matrix must be a symmetric matrix. Here by taking a 2 cross 2 symmetric matrix like this, A equal to 1 to 2 3, by finding the inverse of this matrix we got A inverse equal to this. By interchanging the rows and columns, if this matrix there is no change, again we are getting the same matrix A inverse, that is why A inverse whole transpose equal to A inverse. So that is why this matrix is also a symmetric matrix. So dear children, hope you understood the class today. So still if you are facing any problem, simply so post your doubts by clicking ask a doubt icon in Webmaster app. So thank you for subscribing Master. So please inform to your friends also. So keep learning. So let us discuss some more problems in next class. So thank you, my dear children.